Good morning to all our attendees. We are thrilled to have you all with us today for our webinar on UFS 4.0 Protocol Analysis, Validation, and Conformance Testing. My name is Pranav Jagdish, and I'll be your host for today. We have two esteemed presenters with us today, Mr. Godfrey Coelho and Mr. Brijesh Chandra. Godfrey has over 25 years of experience in the test and measurement industry, and Brijesh is a seasoned technical lead with a wealth of experience in designing and validating high-speed protocols. During the webinar, our presenters will share their knowledge and experience on UFS 4.0 protocol analysis, validation, and performance testing. We encourage all of you to participate very actively by posting questions on the Q&A window. The last 10 minutes of the webinar will be devoted to answering all of your questions. Please note that the webinar will be recorded and a link for the recording will be sent to you after the session. So if you experience any connectivity issues during the webinar, don't worry, you won't miss out on any valuable information. Now, without further ado, I would like to hand over to our first presenter, Godfrey. Over to you.
Thank you, Pranav. I really welcome all of you again. So my name is Godfrey Coelho, and I'm going to talk about some portion of the presentation, and then Brijesh will talk about it. So our main focus today is M5 5.0, UniPro 2.0, and UFS 4.0 overview and exerciser or a tester and how we do protocol analysis. M5 is actually a 23 gigabit, 23.32 gigabits per second data rate. Some of the unique features of M5 is just not the data rate. There are new features like a high-speed link startup. That means previously there was the link startup used to happen only in PWM Gear 1. Now there is a option available for all the deployers of M5 to do the link startup at 5.0. And when it comes to UniPro 2.0, in UniPro 1.8, the DL data payload was maximum is around 276 symbols. But in UniPro 2.0, the payload has become a jumbo and it can go up to 1,138 symbols approximately. And then on top of it, you have a UFS 4.0 protocol. Yeah, okay. So that's the overview. We are going to talk about it. So let me add the agenda is a Prodigy Technovation, M5 specification overview, UniPro protocol package. We are not going to talk much about UFS 4.0 because UFS 4.0 is almost similar to UFS 3.1. And most important part is how do we do the protocol analysis in case of a UFS 4.0? What are the different challenges? We will look into that. And then we talk about a little bit about Prodigy's protocol analyzer and the tester capabilities or exerciser capabilities and UniPro and UFS CTS. So about Prodigy, I think some of you are new to our webinar. We have been conducting webinar for the last 2 years. Those who do not know about Prodigy, we have started in 2009. Today, we are almost a 14-year-old company. We started developing some application software for the oscilloscope. And now, sometime in 2015, we started developing our own hardware-based protocol analyzer. The first product was eMMC, and today we have UFS 4.0, PCIe Gen 3, Gen 4. We are almost now 60-member team. All of us are located in Bangalore. Most of them are working on product development. And we have a customer support team who are providing all kinds of support at different time zones. They are all the time available almost in different time zones. We have distribution teams, like we have distributors in Japan, Korea, Taiwan, China, Southeast Asia. Then we have in France, Germany, Italy, Israel, and we do directly reach out to customers in India as well as in the North America region. That's about Prodigy Technovation. So coming to the key features of UFS protocol analyzer, It is fully backward compatible. It supports M5 3.1, 4.0, and current version of 5.0. When it comes to UniPro, again, it is a backward compatible. It supports 1.61, 1.8, and 2.0. And also UFS version 2.1. We do support 2.2, 3.0, 3.1, and 4.0. So almost we cover all the versions of the M5, UniPro, and UFS specifications. We do have a support for PWM, gear 1 to gear 7, and high-speed gear 1 to gear 5, and A and B rate series. One of the unique feature of our product is continuous streaming of the protocol data to a host computer. We are the first in the market to have this feature. So when the data is captured from the device under test, we immediately transfer to the host computer that will allows you to capture the data for a long period of time. We have different probing solutions, like we have enhanced our probing solution as the data rates increase. You will see that in the coming slide. One of them is a solder down active probes. Then we have a board to board. Different probing solutions are available to address different requirements. Decoding at M5, UniPro, and UFS layer simultaneously is available. You can do a hardware-based protocol aware trigger based on M5 packet content, UniPro packet content, and UFS layer packet content. And we also provide the flexibility to upgrade the hardware with the latest version of the firmware, and also you can do a field upgradable of the UFS protocol analyzer to a tester also going forward. The decoded data packets can be exported to a TXT or a CSV file format. And this is a very compact solution. Like many times you need to visit customers and give a support to them. And you really no need to carry a very bulky unit. It's a small and very compact unit, almost size of a laptop, but slightly heavier than that and slightly higher thickness. But it is quite portable and easy to carry it around. The UFS tester, which we are talking today, one of the key focus today, it is industry's first UFS 3.0 and 4.0 protocol tester, which is thoroughly tested on multiple devices and working pretty well at HS Gear 5B data rate. So users can write their own custom test cases, like you can write your own test cases using our script. We will talk about the script later in the presentation. You can write PACP, UniPro, and UFS layer test cases depending on your own requirement. We do provide you few sample test cases, but then you have a flexibility to write your own test cases and save them and recall them. You will also have a API support going forward so that you can do the complete automation of the test setup. It supports M5 UniPro 1.8 and 2.0 and UFS 3 and 4, M5 5.0. UFS Conformance Test Suite is available all the way data rate up to HS Gear 5B. UniPro 2.0 Conformance Test Suite also is available. And UFS4 Protocol Analyzer can be upgraded to UFS 3/4 exerciser and testing capabilities. A typical test setup would look like this. You have an analyzer and then you have a UFS tester board. So the analyzer will also have a traffic generation. This will be fed to the tester board, and this traffic will be injected to the device under test, just to show you the test setup. And the TX traffic of the device, that is the traffic of the device, is acquired by the protocol analyzer, and it will be analyzed and displayed on the software tool, which is running on Windows PC. This is how a simple test setup would look like. It is very easy. You can easily deploy in the field. Okay. So let us come into the overview of M5. As we talked about, there are different gears in M5. High-speed gear 1, it starts with 1.25 gigabits per second at rate A, and rate B, it is at around 1.45 gigabits per second. So all the way up to it is gear 5, the rate A is at 20 gigabits per second and rate B is 23.32 gigabits per second. The PWM gear starts with gear 0 to gear 7, but in case of UFS, it is PWM gear 1 is used that can vary from 3 megabits per second to maximum of 9 megabits per second. This is where the initialization takes place between the host and device. Once the initialization activities are complete, it will move to the high-speed gears. But now with the M5 5.0, you also have a flexibility to start the initialization in HS gear 1A starting at 1.25 gigabits. That gives you improves your initialization performance. So basically, it's a two-lane system, but you can configure as the way you want it using the power mode change packets. Okay. So power mode change package, you have 2 TX and 2 RX, but you can configure as a 1 TX and 2 RX or 1 RX and 2 TX using the power mode change packet. You have all the flexibilities. The current specification is supporting 2-lane, 2 TX and 2 RX. So maximum throughput you can go almost in each direction is around 46 gigabits per second full speed. A packet when the data transfer takes place in a burst mode. So it is very important that if you compare to most of the protocol, high-speed protocols, there is a continuous activities happening on the line. But in case of a UFS or a M5 specification, there are different modes are available, fast auto mode and fast mode. When there is no traffic data to be transferred, so you can close the burst. So you can put the device on a fast auto mode, and when the data is there, it will transfer it and it will close the burst. But in a fast auto mode, when there is no data transfer is happening, it will be sending some packets, pillars packet data, and it will be keep the bus very active, and that will maybe enable the bus to come back very fast compared to the fast auto mode. So you have a stall mode and prepare mode and adopt and sync and marker 0, then followed by the filler data marker 0. In case of a PWM, you will have a sleep and prepare and continues like this. Okay. Now, if you look at this information on a time domain, this is how the data would look like. You have a prepare condition. It's like a pulse. Okay. And then you have a sync length. You will send the sync symbols on the line. These sync symbols are received by the receiver of the device or a host and helps the device to lock to the incoming data. So if you observe that the data can come at gear 1, gear 2, gear 3, or gear 4. So it can be different at each burst. So every time the receiver needs to lock to the incoming data, and that's where the sync symbols are used. Normally, every product can be configured to send maybe 64 sync symbols all the way up to 4 kilo symbols. So depending on the signal integrity, maybe requirements and the requirement of the receiver's locking capability, so sync symbol length can be varied. Okay, and then you have a start of burst and then the DL data packet. And in between the DL data packet, there can be fillers. There can be fillers within the DL data packet. So there is a lot of combination is possible. And end of the burst, there will be a PSCP packet. That's a power mode change packet. That's the M5 layer packet. This will have a information whether bus should go to the sleep mode, stall mode, or a hibernate mode. And then it will come back again. And it will also have the information what would be the data rate of the next burst. Like this burst can be at HS gear 1 and the second burst can be at HS gear 5. Okay. So all this information will be present in a PSCP power mode change packet information. Okay. So now this is about the M5 layer. Now let us look at the UniPro layer protocol challenges. Like one of the most important part is connecting to the device under test, and then how to acquire low speed and high speed protocol data, and then how to analyze the data. We will talk about more about connecting to the DUT today in the presentation because we just have a 60 minutes of time and we cannot cover everything in detail. But in case you need to have more information, you can always reach out to us. And acquiring the low speed and high speed analysis of the protocol data, these 2 points we will cover more in our demo activities, but this one we talk about in this presentation. So what are the challenges of connecting to the DUT is that, so the M5 is a very different than most of the high-speed serial links. It is a DC coupled link compared to most of them are AC coupled. And this has a 300 millivolt of common mode voltage compared to others has a higher voltage. Then there is a prepare state of the burst. Like I mentioned, you right, you have a prepare condition at the beginning of the burst. It is more like a pulse, right? And we need to acquire that information accurately in our protocol analyzer. So we need to also have a DC coupled performance in the protocol analyzer. So the signal amplitudes are very quite low. It can be starting from 200 millivolt to 300 millivolt, though the spec is starting from 70 millivolt to 350 millivolt. Most of the times we are seeing DUTs are working at around 180, 190, 240, 230 millivolt range, and that's such a low amplitude signals. And this signal actually is not directly compatible with the FPGA transceiver. So you need to have a strong front-end analog circuit which will make it compatible with the FPGA. Then you have an embedded interface. It's a differential 100 ohm PCB. So it's a very high-speed signal. You need to make sure that there is a proper impedance matching is happening. And you also need to tap the signal at a very high speed, that is 23.32 gigabits. This is a very common problems in M5. But then when you are developing a device or a soft, you do a lot of FPGA-based prototyping. That's in the pre-silicon environment. So it is very challenging to see that how to probe that. Okay, if you want to look at the traffic between the host and device, when you run a test case, what's exactly being transferred between the host and device using a protocol analyzer, it's very complicated to probe that. So how we solve this problem, we will see it in the next slide. So if I mentioned that this is how the M5 signal will look like. You have a 300 millivolt common mode voltage and amplitude of the signal is around 250 millivolt. So we use a active probe tape, okay, which has a signal conditioning circuit and a driver circuit. Basically, this active circuit drives the signal amplitude to almost around 600 millivolts so that the whatever losses happening in the cable will not impact so much at the transceiver end, okay? And also it will add common mode voltage so that it is also compatible of the FPGA transceiver. This is how the first point we address, having a active probe tape right at the probing location, okay? And now look at the device under test available in the market. Most of the devices, if we look at, these are embedded products, right? So the product, like you have a host and device, and there won't be any connector in between them. There is a PCB trace going from the host to the device, and sometimes for the debug purpose, you make these test points available at the device endpoint, and you have a signal and signal. We strongly recommend to have a ground points along with this signal so that we can solder the probe to these test points and also connect the ground of the probe tip to these test points so that we can reduce the ground loop and reduce the overshoot and undershoot, the signal ringing problem, so that we can acquire the signal accurately from this test point. Okay, so we can say ground, signal, ground, signal, ground. Okay, so this is a combination we will suggest you to have on your track PCB in case you have a traces on top layer of the PCB. Okay, so you can use the soldered down probes and you can solder them to the test points. And then you can use the jumper wire. It's around maybe 3 to 4 millimeter in length and solder to the test point and also connect to the ground. And these probe tips, right, they have a CTLE built into it because we are trying to see a signal running at 23.32 gigabits. when we access these signals, there will be some sort of a noise gets introduced. There is a signal integrity issues, and we need to correct that using the CTLE. And this CTLE equalizer is present right in the probe tape. You see that the blue wire, the blue connector, which is actually controlling the CTLE, and the black wire provides the power to the probe tape, and the mini SMP connectors, they drive signal to the protocol analyzer. Now, the second type of development platforms where there will be a mini SMP connector on the evaluation or a development platform when you are developing, validating a SOC or a device. So normally use a power divider circuit, and from the power divider circuit, you bring the signal to the mini SMP connector. And now we need a probing solution that it can directly plug into these mini SMP connectors and take it to the protocol analyzer. So we have a probe tips which has a mini SMP connectors. These mini SMP connectors can be connected to the DUT mini SMP connector using a very short, almost around 3-inch long mini SMP cable. Like no, both end it will have a mini SMP connector, and one end will go to the device under test, and another end will go to these probe tips, and then we can drive the signal to the protocol analyzer. Okay, and again we have a CTLE present in these probe tips, which will do the correction for the signal integrity problems. So we looked into two things. The third option, which I talked about, is a pre-silicon platform, where we have pre-silicon development where the SOC can be present on a FPGA platform, and then you have a FPGA test chip, and then it may be connected to a device, and that can be an actual device, or this could be another FPGA platform, and these two are connected using a mini SMP coax cables. Okay. Now there is no way you can probe this signal because these are all through the mini SMP connector. You have no access to the M5 signal. Now, how we address that is we have developed a power divider interposer board. This will sit between your development platform, and we can connect your host side of it, one end of the interposer board, and the device side connected to the other one. Now, the communication, the signal will go from the host to device using a passive circuit. There is no active circuit present between the host and device. Through the power divider circuit, we are tapping a small portion of the signal and taking it to our active probe circuit and driving it to the protocol analyzer. You have a mini SMP connectors here. They will drive the signal to the protocol analyzer, and then you can do the protocol analysis. So we have tested this solution to the full speed, and it works quite well. So the next, like in the technology, like in the mobile devices or some embedded products, you have no traces on the PCB trace or no test points are available. Now, this is the most complex problem we are in, right? So how do we solve this problem is that Prodigy has developed a board-to-board interposer, okay? There is two boards. There is one small board. The size of the small board is same size as UFS device. I think it's somewhere around 11 by 13 or something like that. It is exactly same. So in place of UFS device, you can solder our small PCB board to the device BGA points. And then on top of it, there is a connector available, and that has a height of around 5.2 millimeter. And on top of it, you can keep this our interposer board on top of it. And this has a gripper socket, so you can keep different devices and check how it is performing. And a portion of signal, which is taken to our active probe tip circuit, and then it is available at the mini SMP connector to take it to the protocol analyzer. So this is how we are able to probe the signals when the test points are not available on the top of the PCB. The signals are connected between the host and device, in between the layer, and we can still able to access these signals using a board-to-board interposer And this is being tested again on multiple platforms, and the results are very, very good. Okay. So in summary, we have four types of probing solutions. One is the soldered on probe tips. We have a long wire. This can be around 4 to 5 inch, which we can solder to the test points, and output will go to the protocol analyzer. If your DUT has a mini SMP connector, you can solder to the connect this one input of the probe tip to the device under test using a short mini SMP cable, which will provide along with the probe tip, and then you can connect to the protocol analyzer. Then we have a P4012 interposer mini SMP probe tip. This is mainly for a pre-silicon development environment where you can connect your host and device and still monitor the protocol activity at full speed. Then you have a board-to-board interposer, which is when you do not have access to the signal on the top layer of the PCB. The signals are in between the layer and you still want to probe them and look at it. And this is your best solution for it, the board-to-board interposer. You can solder the board. And why we are providing this 5.2 millimeter height is that because there are other components which are adjacent to the UFS device, they have a certain height. There can be small heat sink also, maybe a small capacitor. It will not allow you to place the interposer easily. Having a 5.2 millimeter height, it makes it convenient to probe it. Now, in case if you have some DUTs, which has some large components around your UFS device and the 5.2 millimeter is not sufficient, we have developed a custom probing solutions where the size of the interposer is almost same size as the UFS device. And then we'll take out the signal to another breakout board, and then we'll do the signal conditioning and drive it to the protocol analyzer. So based on the needs, we can customize the solution. And also, these are the solution available at this point off the shelf. I would also like to say this, Prodigy is continuously investing and doing a lot of research and what could be the better solution to fulfill the customer need. If you have some unique requirement, please do contact Prodigy Technovation, and we were very confident that we can find a solution for your need. Okay. So these are some of the test setups we have, like we are probing a mobile here, and where we have connected a B2B interposer, and we are able to capture UFS4 signals using this setup. Today, we are not giving a demo with this, but if someone wants to see a demo, you can always reach out to us. We are focusing more on a tester demo today in this webinar. So the protocol analysis, yes, we have a multiple views. We have a UniPro, UFS, and 5-layer view. So if you select a UniPro layer, it will highlight where it is in the, if you select a UFS layer packet, it will highlight where it is in the UniPro layer, and it also highlight the corresponding symbols in the symbol view. Now, if you selected a UniPro packet, you also can link it back to the UFS layer. So it is cross-linking is possible between the UFS to UniPro as well as from UniPro to UFS layer. So that's about the UFS analyzer and probing solution. I would like to now hand it over to my colleague Brijesh. He will now present about the UFS exerciser and also known as a tester solution. Thank you.
Thank you, Godfrey, for introduction. Okay, so here this setup is already explained by Godfrey that this is our UFS exerciser PA unit. So from that we can connect to TX to the tester board, and then we can place the memory on the gripper socket. Okay, and we are working on another solution where user can, if they have a device on their development board, so we are providing one mini SMP connector instead of placing the memory on the board, so they can connect the development board to this, and we can generate the traffic. And similarly, we have RX on the analyzer path, and it is connected to PC. Okay, so we have same software. Okay, so analyzer plus exerciser is in the same software, and we can generate PACP packet, UniPro layer packet, UFS layer packet from the exerciser, and we do support latest specification, and we can generate PACP power mode change packet, PACP get set packets from the exerciser. It is our own scripting language, and we do support API. So you can write your scripting in the Python, and we can from the Python itself you can generate the all the test patterns to test your device, and finally we can generate the report in UniPro view as well as UFS view. Okay, and we can generate report in CSV. Next, please. Okay, so as I mentioned, we have one software which can do analysis as well as exercise. So you can go to view and you can select exerciser view. Okay, and next. So we have all three levels of control: M5, UniPro, and UFS layer. We are not using any 5 chips, so we have very good control over the all these three layers. Okay, so as we have mentioned here, right? Scripts provide choice of different each attributes for the different gear, and this in the right side we have this config view. Okay, this is for the M5 related parameters. We can change prepare length for each gears. Okay, and for each burst also we can vary, and similarly we can change the sync, we can change the trailing clock, we can change the inter message gap. So between two DL data or between two UFS commands you want to give some delay, so that delay is also configurable. Line reset, so line reset also it is configurable. So because in old 3.1 spec, it is like line reset was less more than 3 millisecond, but in new spec it is around 300 microsecond. So we do support all kinds of line reset, and you can test, okay, what is the minimum and maximum line reset time is required. And then we have one idle time. Okay, so it is like between two bursts we can change the gap actually. Okay, so that is also programmable. So all the M5 parameters are programmable with config window. Next, please. So this is UI how it looks like. Okay, link startup. We have written script for link startup. Okay, here we have given prepare for PWM, trailing clock. After that, inter message gap, line reset, and idle time between two bursts. Okay, so it is like packet UniPro, and just give LSLSS. So it will, once you click on run, it will generate the LSLSS traffic. It will do the link training, whatever is required. It will send UPR0, and it will do the handshake, and it will extend the capability packets. So we have separate PACP view. It is very powerful view because we need to see that, okay, what kind of activity has happened on the line. So we are time stamping it. So if you click on this PACP view, it is linked to UniPro view, and UniPro view is linked to 5 view. Okay, so these views are interlinked, so we can do our analysis faster. Then this is like we are sending the power mode change packet. Okay, so here we can give prepare, sync, SOB in one lane, PSCP, and here we have given full control to the user, saying that whatever parameters user data you want to send, you can configure that. Okay, and we have given byte level control at the UniPro level, so you can generate the whatever PACP packet you want to generate, and then we can end the burst. Okay, so you can see here in the UniPro view, we have sent no outs and then power mode change packet. Okay, and yeah. Okay, next I will cover in live demo also. I'll explain in detail. Then we can generate the read 10 traffic. Okay, we have written, we are giving some preloaded scripts also, so you can load it and you can execute it. Okay, next, and this is for write 10 script. Okay, we are sending write 10 command, and then we'll send the data out. Next. And yes, we do have error inject capability. So if you want to insert CRC error for the UniPro layer, so you can mark it as true. So it will send the proper CRC, and false means it will send the CRC error. So that way you can test, okay, if CRC error comes and how your DUT will behave for this behavior. Next. Yeah, so I'll give this CTS demo. Okay, this conformance test is UniPro conformance test is from MIPI, and UFS conformance test is from JEDEC. So we have implemented both the CTS, and for some recommendation is there for the emulation. So whatever exerciser we have, it is host emulator. So uh, that will generate host traffic, and you can test your device development board, or in the if it is chip is available, you can test in the chip. Okay, and it is like we have given full flexibility. So if some new feature is not implemented in the SOC, okay, so we can generate those type of commands also from our exerciser. Whatever reserved commands are there, those commands also we can generate from our exerciser. So it is like in the early stage you want to test some feature on the development board, that also we can do it with our unit. Okay, so next. Yeah, I'll give the live demo for that. I'll share my screen. You, Pranav, you can see my screen, right?
Yes.
Okay. So this is how our UI will look like. Okay. So I'll just quickly guide through this UI. Okay. If you have captured the trace file, you can do the offline analysis while using this feature. You can save this, and some configuration you can do import export. And there are some views we have predefined views we have used. So you can select any of this view. Okay, and all these views are dockable, so you can place it wherever you want. If you have multi-monitor system, you can place in different monitors and you can analyze quickly. Okay, then we have device config view. So here we can do the configuration, rate A, rate B, or rate A plus B. And we do support high-speed mode link up, as Godfrey mentioned in latest spec, UFS M5 latest spec. It supports high-speed link up, and we do support all the clock frequencies. Okay, and this is to acquire the data. We have to configure this channel assignment. Okay, and if on the prop tip, if on the test point, if you have connected P to N and N to P, okay, so that time you no need to resolder on the test point. You can just select the invert option, so that can be handled. And these are some other features. Okay, PSCP power gear, and we do support up to maximum gear 5, live capture, post, you can do post capture analysis. And we do have hardware filter in AFC. For each DL data we may get multiple AFC packet. So if you are not interested in those packet, so we will just take the first frame sequence number, and remaining AFC packet we will drop at the hardware level, so you can capture more. And then DL data payload drop feature we have. So if you are only interested in UFS packet, you can select this option. Then we have 16 GB of circular continuous buffer. we do have circular buffer and some error analysis. We can save the trace file. So I'm quickly going through this demo, but if you are more interested in that, you can contact us and we can schedule separate demo for you. Okay, then we have UniPro view, file symbol view, and all. So these things are interlinked. If you click on this right UFS view, so it will just automatically update on the UniPro view. If you click here, this UniPro view, frame view, as well as symbol host view will get updated. If you click on device side traffic, then UniPro frame view for appropriate packet and device side view will get updated. And we can set unlimited markers. You can rename your marker, you can go to marker, clear all the markers, and if you want to save some markers, you can do it. And if it is like you want to see the details of the uh, packet, you can click here. So all the flags we will decode here and show here that okay, what is the meaning of this flags. Okay, so this is what, and then we have you can add the columns. Okay, whatever information is required for you, you can select this from the hide and show columns. Okay, so if it is not required, you can just ignore it. And this is what for analyzer. Now I'll just quickly show the exerciser, and we do have some search and filter, powerful search and filter uh, view where you can analyze quickly. You can analyze, go to that packet, and you can find out. So those features are analyzer features. But now I will just quickly give insight on our exerciser. Okay, so here script. So this config, as I mentioned, it is for M5 related parameters. All the parameters you can vary. Though in the capability packet we have set some capabilities values, but from this you can override those values. So this is very powerful feature if you want to debug your file layer thing. Then we have a packet. So in packet, if you are interested in UniPro layer packets or UFS layer packets, we have both the options. Once you click on UniPro, you can see, okay, what are the different things we can do. We can do LSLSH, HSLSS, PSCP, okay. And it is like you want to check some error conditions, like you have set power mode change packet in one lane, but you want to generate traffic in two lanes. So those and vice versa, you can generate from our exerciser. Okay, so this is one thing. Then in PSCP, this capability packets, anytime you want to send these packets, you can do it. You want to send some get request, set request, you can generate this request from exerciser anytime. Okay. And UFS. In UFS, we have given raw data, okay, where some commands are reserved, and it is like you want to test specific to that command. So you can enter in the byte format. Okay, so this we will send on the line. So you can test some reserved commands also. Then we have no pout, query request, and command. All these things are what means once you go to that stage, what are the possible options are available from the spec. We have covered in the scripting view itself. So if we go to command, we have listed all the possible commands what are there in the spec. Okay. So once you go to, let's say you want to send read 10 command. So in read 10, whatever the configuration, configurable fields are there, we have listed down here. So you can select this and just write those values, and you can keep add those values. If you don't enter, it will be considered as a reserved and it will send a 00 on the line. Okay, so this is what we can generate from our exerciser. So M5, UniPro, and UFS layer traffic you can generate. So now I'll give you live demo for HS Gear 5B. Okay, so uh, okay, we have some preloaded scripts here. So I'll quickly go through this. So LSLSS, if I send, okay, so it will send LSLSS and immediately it will decode. So if you see here UniPro view, it has sent UPR0, UPR1, all the handshake has happened properly. Okay, and exerciser, I'll send some knob out. Okay, I've sent multiple times. So it will get decoded. Okay, and here it got decoded in the UFS view. Okay. Now I will change to gear 5, one lane fast auto mode. This is PACP packet. I will send this. Then I will just send NOP out. Okay. So it will send NOP out packet in gear 5B. So here, if you see this packets, right, it is in the it is saying that so here it is saying that TX mod 4 one lane and gear 5. Okay, on RX side also it is same. So with our exerciser, if you want to set TX side one lane, RX side two lane, or TX side two lane, RX side one lane, all this possible combination you can generate from our exerciser. And we got the confirm for the gear 5 one lane. Then I have sent some knock out packet. Okay, and exerciser, I will send some script. I have okay multiple. See, you in this you can write the combination of UniPro UFS packets in one script. Okay, so it is like one here it is one burst I am sending, but you can make your test script for multiple burst also and multiple commands. Okay, so we have some buffer in our exerciser, so which will store that many scripts and it will execute. So once those scripts are executed, we can send one next scripts. Okay, so I will send some read commands multiple times. Okay, so here it will get decoded. Okay, okay. So no out. I got read 10, it did not respond. Rerun more time. So as you can see, gear 5, I have sent multiple read 10 commands. You can see here, I have sent 4 commands 3 times. Okay, so we can see here in the analytics view that I have issued 12 commands. And with pie chart, we can see, and we have column chart also, that how many times read 10, no outs, no pin, response, or data in came on the line. So those things we can see. And I'll now show you the UFS CTS. Okay, so we have UFS CTS. Okay, so we have listed all the CTS commands here. Okay, so you can select whatever CTS test scripts you want to send. You can select this test script and you can send on the line. Or if you are interested in all the test case, you can select all the test case, and once you click on run, we'll send one by one all the test case. For now, I will just select this 5 test case and I will just send it. Okay. So once it is sent, it will say it is sent and it will get updated in the end. Okay, so these are the test cases it is running and if it is sending. So we can see here there are 5 times inquiry test, 5 different test cases are there. So actually this is first test case. Okay. So it has responded properly, but here there is this page code is 83, it is unvalid, so it has not sent the data in, and it has given as an error. So this is how you can quickly test your design, that how it is behaving for the UFS CTS. Okay, and then we have, similarly we have UniPro CTS also. So there we UniPro CTS is around 165 test cases. So you can just select all test case and you can give run. So it will send one by one, and we in the end we will give the report. Okay, so currently we are working on showing the report how it looks like, but we do have one I3C exercise at CTS. So similarly, this report also will look like it will be same thing. This is our another product where we have I3C CTS, 56 test cases. We will say pass and fail, and wherever it is failing, we will display that. So similar thing we are implementing for UFS and UniPro CTS. Okay, and then we have report view where you can generate the report and export as a CSV file, UniPro report, and whatever the parameters you want to include in your report, you can select. If you are not interested, you can disable this. So those columns will not come on the CSV report. UniPro report, we have given all the, if you are interested in some starting to some point of the index, you can select that index, or if you are interested in all the index, you can do that. Okay, so this is how this is what we wanted, that this is what I wanted to cover in this webinar. um, Godfrey and Pranav, I'm done with my presentation, so now maybe we can start with
Yeah, thank you, Brijesh. Yeah, thank you. Thanks a lot. And Pranav, you have any questions from the audience attendees today? We have
Yes, Godfrey, yes.
maybe 7-8 minutes. We can take few.
Sure.
And please feel free to present your questions. And if you need to contact you directly, please make a note in your chat box. We can also contact you.
Okay. Yes, Godfrey, we have few questions. So the first question is CTS an added or included in the analyzer and exerciser with the purchase?
CTS is an option, okay, so which can be upgraded. You can buy the analyzer today, and as and when you need see a conformance test suite and tester capability, you can add the tester board, and during that we will upgrade your firmware of the hardware, as well as we will give you the new software and the tester board, so that you are ready to do the conformance test suite test cases.
Okay. So the second question is almost similar. The question is, if we already have an analyzer, can we add an exerciser?
Yes, if you already have an analyzer, we may need to go through some hardware upgrade path, and we will be able to upgrade that at a minimal cost, actually. Yeah.
Okay. The next question is, what to do if the test points are not accessible on the board?
Yeah, we can use the board-to-board interposer, where we can bring out those test points to the mini SMP connector in our interposer board. So we have a separate video on that. You can go and take a look at it on our website. And if you need more details, I request attendees to write to us.
Okay. The next question is, can I change the color of the UFS layer, UniPro layer, for easy identification of packet on your software?
Yes, I think we can change the color of the different read, write operation, data in, data out, background change of the particular row, or we can also change the color of the font. We can do all that. So here in the GUI, you can see, Brijesh maybe can explain that little bit more detail.
Yeah, so if this commands, this read we have sent, right? So if we want to change color for the read, see this is background color, it got changed. And if you just click on reset, it will go off. So background color and font color we can change. Okay, so it will update immediately. So similarly, you can do it for UniPro view also. So if you want to do it for UniPro view, you can do it like blue color. So this become blue color, and if you reset, it will go off. Yeah, Pranav, next question.
Okay. The next question is, if buying the analyzer or exerciser, what are the standard accessories and probing solutions provided?
While buying the exerciser, analyze. So if you're buying only the analyzer, we have an option of selecting either soldered on probe tips or mini SMP probe tips. And optionally, B2B interposer and board-to-board interposer is board-to-board, and a power divider interposer for pre-silicon is available. And if you have some unique requirement, we can also provide custom probing solution. As for the tester is concerned, we are providing a UFS tester board, and then there is a additional firmware we will provide you to the hardware FPGA logic and so updated software, which will support all the tester capabilities. These two are requirement, like comes as a standard with the analyzer and for the tester, when also get it when you do an upgrade. There is a question from Yakov. Maybe you can ask this. Yeah, HSLSS. Pranav, we are not able to hear.
Yes. Yes. So there is one more question. HSLSS has GPIO been set to set bit, bus loading, especially gear 5, ability to work with low amplitude signal. Is there a minimum specification? Auto ref clock and rate tracking, built-in termination, credit size support.
Okay, I'll take this question, Godfrey. So
Yeah, Brijesh, right.
yes, we have provision to provide that LSLSS GPIO pin. So with that pin, we can do switching from LSLSS or HSLSS. So that provision is from analyzer to the tester board. It is there. And then next question is, yeah, credit size. Also, we do support both the credit size, 32 byte as well as 128 bytes. And yes, bus loading SP. Yes, we do support this thing. We can track the rate also. Yes. Next question.
Okay, the next question is, what is the total buffer size of the capturing trace?
Yeah, so let me take this question. In the analyzer, we offer a 16 gigabytes of standard acquisition memory, but then you have a flexibility to upgrade this memory to 64 gigabytes on the feed, depending on your need. It is 16, 32, and 64. Depending on the need, you can buy that, but standard 16 gigabyte is available. But when the throughput is small, right, like there are small events are happening, we also provide a streaming capability. Normally, that allows you to capture the data for beyond 64 gigabyte also, because once the data is captured, stored in the buffer, in the acquisition memory, transferred to the software, but then immediately that memory is freed for the next upcoming data inside. So you can capture actually for a longer time also. Yes.
Okay, thank you, Godfrey. There's one more question. I would like to ask, does the tester, exerciser, and protocol analyzer have a function that sets the size of data to test the read or write performance for the UFS device?
1 minute, I would like to test data to. Yes, we can do this. Okay, for write we may have some limitation. It is like for write we cannot do our performance test. Okay, but for read, yes, we do support full speed in HS Gear 5P 2 length. Okay, so during read you can test your performance. There is one more question, is original view settings. Can we save the original view? Yes, it is. Okay.
Brijesh, I have a question. How much write data we can do? Any buffer size there?
Currently we have 64 KB.
Okay, so maybe can you use API to push more data?
Yes, we can do that.
Okay, yeah.
Right, we are planning to give some 1 GB or something,
Okay.
but we'll see. Based on the feedback, we can plan.
All right.
Okay. So let's go on for the last question for the session. So what are the plans for UFS 5?
Yeah, we are actually actively involved in MIPI Alliance working group. We are a contributor member, and we are been closely monitoring M5 and UniPro specification and how it is evolving. And we will working on seriously based on the requirement in the market, availability of product to UFS 5 as and when required.
Okay, thank you all. Thank you all for attending our webinar, and thank you, Godfrey. Thank you, Bujesh, for the session. If anybody wants more information, you can always email us at contact@prodigytechno.com or visit our website for our other product offerings too.
Thank you everyone.
Thank you. Bye now.